but I'm going to flop back here so you can see what the first notes are. All right. That is the first notes. Okay. All right, moving on. Was everybody ready? All right, so now if we talk about this angle, remember we said that this goes on forever and ever and ever, right? Ever and ever and ever and ever and ever and ever and ever. So we can talk about the interior of an angle, or we can talk about the exterior of an angle. We can also talk about interior angles and exterior angles, but today we're not talking about interior angles and exterior angles. We're talking about things that lie within the interior or on the exterior of the angle. Does that make sense? So point Q. So interior, inside, right? Exterior, outside. Interior, point Q lies within the interior of this angle. If you imagine that those rays extend forever, you can see how that falls in the interior. Does that make sense, Soraya? Okay. So we already said point Q is in the interior, so that's what you're writing in your notes. What are the other two names for angle 2? So here's the catch. Let's go ahead and go to angle 3, example 3 first. Can we call any of these angles angle B? Why not, Louis? Well, because splits what in half? How many angles can we see in this diagram? Technically, there's 3 though, right? There's this big one that you may not be counting. That one, and this one, right? They all 3 have a vertex of B. So if we say B, how do we know which angle we're talking about, right? So we can't call any of those no, because B is the vertex of multiple angles. We can only call that one of those angles B if that's the only angle in the diagram. So who can tell me what are the other two, well, one of the other names for angle 2? What's one of the other names for angle 2? Travis? CBE, yep, CBE would work. What's another one? So CBE, what's another one, Bailey? Or EC, that's exactly right. As long as you have the vertex in the center, the order of those points doesn't matter. So angle EBC and angle CBE, we can use those interchangeably. One is not any more correct than the other. Okay. And this is a protractor. A protractor is a semicircle. It's a half circle. One of the things we want to go ahead and just throw out there, make sure you know there are 360 degrees in a circle. All the angles we talked about is all the number of degrees out of 360. Right? The most degrees any angle could have would be 359. Well, 360, I guess, is the circle. So the protractor is half of that. So you can see here it starts at 0 and goes to 180. Or the inside of that arc here starts at 0 here and goes to 180. You can use either of those numbers. If you use 0 here, you got to use all the top numbers. If you use 0 here, you have to use all the bottom numbers. So those are the degrees in half a circle. So if we would have more than half a circle, it'd be 180 plus however many degrees goes around on the other side. Does that make sense? Okay. So let's go ahead and look at angle AOD. So A, O, and D. AOD. So I'm going to look at the 0 side. It starts at 0 on that 0A ray. And if we go over to 0D, we can see that crosses the protractor at 90. So that's a 90-degree angle. Marshall? You do not appear to be writing, man. We're right here. Are you feeling bad? Do you need to go to the clinic? Guidance? Anywhere? Please don't put your head back down. All right, let's look at example 5. So now we're going to look at EOC. So a point on this ray, we're going to call that E, O, and C. So now, with these crossed, they don't cross at 0, right? But that's okay. All we have to do is subtract. So if this one crosses at 120, and this one crosses at 50, I can take the 120 and subtract 50 and get a 70 degree, to see that that's a 70 degree angle. The other way is I could look at the C, that ray OC, and see it crosses at 130 on the top, and I could go over here and subtract the other top number. 130 minus 60 also gives me 70. It does not matter which way you go. You said, I feel like you can't see. Can you see? Okay. Let's look at FOA. Can anybody tell me how many degrees are in FOA? FOA. 140? So A is at 0, goes all the way over to 140. That's right. I don't even have to do any math there. If it starts at 0, then you just look at the number that the other ray goes through. And angle BOC, so B, O, and C. What do you think? Alex, how many degrees? How can I find how many degrees angle BOC is? Very good. So it crosses at 50 and 30. We just subtract those. And so it's a 20 degree angle. Any questions?
On our homework, do we need to write like 50 minutes later to do like
I'd like you to write the problem. You don't have to write it on the but if it starts at 0, you don't have to. If it doesn't start at 0, let's say you do. Okay? Alright, so hopefully middle school math taught you these terms. Acute angles, right angles, obtuse angles. Straight angle you probably didn't learn in middle school. Anybody remember what an acute angle is? It's so small, but how small? What'd you say? Less than 90, that's right. So an angle that's less than 90 degrees. What about a right angle? What about a right angle? It's exactly 90 degrees. And if you're not familiar, look at this little square here. That means they've told us that's a right angle. That little square in the angle part here tells us it's a right angle. And that means it's exactly 90 degrees. Obtuse angle. Greater than 90, but less than 180. Now this is just an example. Not all acute angles are 40 degrees. Not all obtuse angles are 115, right? Can't be 90 and be an obtuse as being greater than 90. It could be 90.9, right? But it can't be 90. It can't be 180, but it could be 179.9. And a straight angle, it's just a line, but a straight angle, if you'll notice here, a semicircle. If we go from any one point on the line in an arc to another point, what we've got is a semicircle. A semicircle, half a circle, has 180 degrees. So it's exactly 180 degrees. We won't typically call that a straight angle, we'll call it a line. But you might see that in some other resource or on the EOC, and you'll have to know that a straight angle is a line. Any questions? Congruent angles. What do you think congruent angles are? What do you think congruent angles are? Hayden, what do you think congruent angles are? What are congruent segments? What do we know about congruent segments? Yeah, so congruent statement or the same length, and we would say congruent angles have the same measure. So congruent means the same. So we're going to say, remember we were talking about congruency and we had little dashes of the segments? When you're talking about angles, they're little arcs. So one arc here and one arc here tells me, I don't know what those angles measure, but they're congruent. I'll tell you, Gregor, give me a second. Angle 1 is congruent to angle 2. They could have indicated that with 2 arcs, as long as they did 2 arcs on both angles. The only way to name these angles are angle 1 and angle 2 because they didn't give us anything else. Gregory? You good? Okay. All right, so who can give me the name of the sides of angle 1? The name of the sides of angle 1. Who haven't I talked to? Jesse, can you give me the sides of angle 1? What kind of figure are the sides of an angle, Jesse? So back in the notes if you need to. We talked about what is the definition of an angle. What is the definition of an angle? What's the definition of an angle, Jesse? By 2A, right? So this side is FR and this side is FT, right? So tell me the sides of angle 1. So not BA, right? Because that would be a segment. We're going to say ray BA and ray BC. But yes, ray BA and ray BC. You have to put that ray symbol on top. How about, for example, for angle 2, Grace Brown? So BC, so is this, if you write this on a test, am I going to give you credit for it? Ray BC, good. Ray BC and Ray BE. Let's give another name for angle 1. Who can give me another name for angle 1? Jed, can you give me another name for angle 1? Angle ABC would work. You could also say angle CBA, but either will work. Give me another name for angle 2. Gerald, can you give me another name for angle 2? Remember, we named it with the vertex in the middle, right? So if this is angle 2, we could also do this or that. So give me whatever. It's going to be 3. So you have to name an angle with 3 points. The vertex has to be in the middle. CBE would work. Angle CBE. All right. So now, example 12. Measure of angle 1 is equal to 3x plus 4. I'm going to put that in there. The measure of angle 2 is equal to 7x minus 2. The measure of angle ABE, so that's this whole thing here, from here to here, that's ABE. So ABE is split into 2 angles with ray BC. Does that make sense to everyone? So they're telling us that that has a measure of 52. So this is similar to the segment addition postulate in that if we have an angle and we use a ray to divide that angle into more than one angle, the sum of those angles equals that angle we started with. Does that make sense, Caleb? So that means angle 1 plus angle 2 equals angle ABE. So we're going to write that. Angle 1 plus angle 2 equals angle ABE. So guess what? Now we have an equation that we can write, right? So now we can solve for x, and then we can find out what the measure of angle 1 is, how many degrees that is. So angle 1's expression is 3x plus 4, plus angle 2, which is 7x minus 2, and it equals 52. And now we're going to go through and solve that equation, combine like terms. And start solving. And I'm doing the solving pretty fast because we're through with that equation unit. So now I know x equals 5. So now they ask me to find the measure. So that m here, that m means measure. So we read that m as the word measure. So the m is read as the measure. One measure of. So x equals 5, so now if we're looking for angle 1, angle 1 equals 3 times 5 plus 4, which is plus 5 and for the x here. So angle 1 equals 19 or 19 degrees. Any questions? All right, let's look at example 13. Now they're telling us that angle 1 has a different algebraic expression to represent its measure. Angle 2 has a different one. And now they're telling us that ABC also is an algebraic expression. So it's still angle 1 plus angle 2 equals angle ABE. You don't have to do that in your notes, but I will tell you that does help organize your thoughts when you write that down, right? So now I can like, okay, what is the expression for angle 1? Oh, it's 4x plus 5. What is the expression for angle 2? It is 6x minus 7. And then what is the expression for angle ABE? It's 7x plus 13. So now we are combining like terms and then getting our variables on the same side and then solving that equation. So 4x and 6x is 10x, 5 minus 7 is negative 2. I want to get my variables on the same side. I'm going to subtract 7x from both sides. So 3x minus 2 equals 13. And 3x equals 15. And x equals 5. So x equals 5. Now, it asks me if these two angles are congruent. So how can I determine if angle 1 and angle 2 are congruent in this example? What do you think? How can I determine if they're congruent? You ready? Expression. So we're going to call that an expression. Yes. So let's plug in 5 for both expressions. So for angle 1, it's 4x plus 5, right? Angle 1 is 4x plus, is it 5? Yes, plus 5. So now we're going to take 4 times 5 plus 5, and now we know angle 1 equals 25. Now we're going to do the same thing with angle 2. Angle 2 is 6x minus 7. So I'm going to plug in 5 for x. 30 minus 7 is 23. Are they congruent? All right, so angle 1 and angle 2 are not congruent. Should you put your date on your notes? I'd like you to put your name and your dates But if you did not put the date on your notes, that's important to kind of keep yourself organized. If you're looking for these notes sometime, that will help you. All right, anybody have questions on anything? Today's date is always in the top left-hand corner, August 24th. All right, so you guys should be working on your review worksheet. If you'd like to scan and submit your notes now, you may. But then you should be working on putting your phone away and working on your review worksheet.